I think I need another extension cord. Nice. Yeah, extension cord for the extension cord. No, I don't. Okay. Um, maybe. Sure. What? You won't go there. Go ahead and start with. Put it like here.
Like the one.
Yeah.
Like it's like. We're living 12, being on 7, but it's literally like. Big window, and it is built in 1914, so not. Well, we don't have air conditioning. We told my whole life there's a mystery to all the window. Is it real? What if? Like what? Like what if they got it? Like what if they knew? Like, never seen it? What if they didn't it's crazy when you don't have your lawn, you're going to use that. How they just do that.
You might have to switch it with the body. That's on the body, so yeah.
Well, this is a this one is like this is a double loaded code. So the next so the windows. Like I said, you would right. And then you get all that's my drum.
做的精致的工作。
精神工作。
是我在看这个话，就是
And we shared our intelligence.
我是做
And then it's about I got like
就是那个
I got some drive.
最后的，而是 like started 那个
Yes, it was a thinking about it.
就是最长的
2 plus 3. So I just have to walk and I won because I'm old. So I walked through my brother's.
babies.
No, he was not.
So it's this part that would be here. So we have to do like that. Or no, it's a different part. I don't remember. I couldn't find it. I'm sure. Pages. Nothing was pages as they picked it. But so that's why I didn't find it. And I think for that one, okay, forward.
Okay. I'm gonna start, everybody. Okay. Please open up Houdini again. While I'm talking about a couple of tiny little things. Okay, I'm next class, if we get through everything I want to do this class, I want to just do the mathematical stuff with you, because I think it's exciting. But I want to mention one thing about it right now, because when we're doing these simulations, I think it's important to know that there are some approximations that are being made. So these are Navier-Stokes equations. I've shown them before. First one is the one that describes the fluid flow. The second one is called the incompressibility condition. This one. And, you know, we talked about gases and liquids and how they're different because gases are compressible and liquids are not compressible. You know, if you can use a liquid to raise something up by pumping it in, and gas, you can push on it and compress it. But gases, unless they are going close to the speed of sound, do not compress themselves. So unless you're doing very advanced sort of things with aircraft, you can basically treat gases as though they are incompressible. So we make the assumption that the gases are incompressible. Then the other thing, this is just an aside, by the way. I haven't mentioned this before. This is viscosity. Okay, viscosity. Different things are differently viscous. there is more resistance drag between the parts of the fluid. But because of the resolution of the simulation, viscosity is often kind of just happens of its own accord. And so we sort of leave it out because there's a drag in the simulation just by the virtue of the fact that it's imprecise and we're sort of approximating values by interpolating. Basically, there's a value here stored and a value here stored, and we interpolate between them to guess what the value is in between. Because of that, there's a blurring that goes on. So that blurring sort of replaces any physical viscosity. By the way, this is very exciting. I don't know if you guys have seen this before. Viscous, truly laminar flow, okay? Truly laminar flow is reversible. This is an amazing thing. Just to be aware of it. You can go all the way forward and blend it, and then choose faster. I get so impatient. Here we go, finally. Okay, look at that. So it's turbulence that's the thing that's causing the blending of the air. It's not amazing. It's like reverse entropy. They do it by making you just take a very skinny area and you fill it with a viscous liquid and you stir it up. So it's like it approximates truly laminar flow. If you have truly laminar flow, it's reversible. So the turbulence model is sort of the main other approximation, right? And then the real approximation, and this is the one that causes a commotion, okay, is we assume in most simulations, we assume something called the Boussinesq approximation. And that is we assume that density is constant everywhere, except due to variations in temperature. And then we assume that temperature varies linearly. And we replace the entirety. So the way it actually works, right, is that areas that are hotter are less dense, and areas that are colder are more dense. And so there's a density difference between two areas of a fluid. But in most simulations, we completely ignore that, and we just substitute a buoyancy force based on comparing to a reference temperature. Okay, so like we will say that if it's this hot, we subtract a reference temperature from that, and then that scales a buoyancy force. So like if it's X degrees hotter than the reference temperature, it'll rise. And if it's X degrees colder than the reference temperature, it'll sink. It's a huge problem, okay? Because if you do things this way, you can imagine if you were outside and it was cold, if you're inside and it's very hot and your reference temperature is set based on the outside temperature, you might get situations where cold air is rising if your reference temperature is very high, or situations where hot air is sinking if your reference temperature is very low. I think I said that backwards. You understand? If you're relating everything to a consistent temperature, typically the real way that it works, right, is like every bit of air, if it's next to hot air that's hotter than it rises. If it's next to air that's colder than it sinks because of its density. But if you're relating it to a constant temperature set macroscopically across the entire simulation, you end up where sometimes air might behave non-physically. Okay, so we have to be aware of that. And that's simply for speeding up the computation. So if you want to do anything in real time, you can't go around calculating the the pressure at every point in all these loops and comparing it to itself. So it's something to be aware of, and if it's behaving non-physically, that's why. And so we need to do some things to kind of correct for that as we go forward. Okay, I don't know if that makes sense. I probably didn't say that in the clearest way. There's an approximation. We're comparing everything to a reference temperature. Okay, this is something that is always happens in Houdini and in my simulator and in any sort of real-time simulator, and it often happens in all sorts of CFD analysis. You'll always see if you read a paper. We use the Boussinesq approximation, and that's what it means. It means that it's not changing the density; it's comparing everything to a reference temperature. Okay, and you'll see that happening in Houdini. Okay, so those are the approximations, and I'll go through that in more detail later on. All right, so this is what I wanted to do today. I wanted to make um, I wanted to make something about my simulation cache that's gotten screwed up. I was going to play this for you in real time, but my cache has gotten deleted. So it'll take a second. Oh, you don't even see my screen at all. But you can see my screen. Hmm. Okay. I think it has to do with probably. Okay. Okay. I wanted to do um this thing with you guys. I made a thing that I think has like most of the techniques in it that you would need to simulate the heat flow in various ways. And so we will create this now together. Okay. So the way this is working is so there's a temperature field, there's smoke that's rising up through a stack, it's heating up as it goes, and then there's all these arrows showing the direction of the flow. Okay. So in order to create that, I created a little building, which I uploaded, this little thing here. Okay. And it has a layer with walls, and then it also has like a glazing layer. And then it has something in here which is going to be my heat source. Right now, I just decided I would just heat up the whole top part as if it was like sun was coming in and heating up this thing. And then it also has a volume for the air of the inside. So then in Houdini, what I can do is I can make a geometry container. And I can go in here and I can go file to get this little thing. One of the things I often do, by the way, is I often just turn off all of this stuff. And you can get the parameters back by typing P. So you don't it makes the screen a little less crowded. So you can get this file node. And the first thing, of course, is to select all of this and go export and save it as a FBX with meshes and do this swap the Rhino Z to the FBXY. And then when you come in here, you can go type P and you can go here and select wherever the file is. By the way, you can make your own if you want. Select whatever the file is. And I'm just gonna finding it. And I get that thing. Does that make sense to everybody? Yes, I'm gonna pause. I want to go slowly. Thank you. Please let me know. Please don't let me just barrel on and be done in 20 minutes and then dismiss you. Uh, Thank you. I always think you guys are gonna be bored. You go like meshes only, and then you go. This stuff doesn't matter. I don't have any lights or views, so like whatever. I think you do want the vertex normals. And this is because Rhino is the only piece of software that for whom Z is up. So you just it's on the server in this Google Drive. It should be called simulations. There it is, simulations. In here are all of my files that I'm showing you. There it is. I already made one, so you can just download the FBX that I already made if you want. This is the FBX, and this is the Rhino model. In Houdini, okay, yeah, in Houdini, first you got to make a little container. So you type tab and you go geometry. You get this little container, and we should name it something. We should call it like building, like and then when we go in there, we also hit tab and type file. There are many ways to import things, but most of them are for importing character animators. And so we can just use the dumb, simple file thing. And this just links to a file. You can click here and find the model. I think, by the way, that the way I named the model might not import. And so, like, I went to the end here and I just changed this to like, look, you can see it screwed up the characters. I just changed it to what it actually was. And it comes in. You click on this little piece of paper with the arrow on it. How's it going, everybody? Oh, black mode. Yeah, if you type D, it comes up that brings up the settings, and you can go to the background and you can check this, change this to dark. And then if you click here, you can get rid of the grid. over there. And then also like up here at the top are the shaded modes. And I also always go here. This little thing will tell us whether we're seeing things that are in other geometry containers or not. So I usually hide all other things that are not in the container that I'm working on. Yeah.
Here.
Yeah. And then the next step, I'm going to do it, but I'll pause, is you can type split and you can drag this in here. And then if I preview this by clicking this on here, I can go up to this little selector and you can see it says it has my layer name and then it has the name of an object. So I can select, and I can select multiple ones of them. So I'm going to select all my walls. I'm just going to go through here and select all the walls. And those are now in this little container. And then I'm going to go, I'm going to make another tab. I'm going to go null. And I'm going to pump that in here. And I'm going to rename this walls. Yes.
Is that just from based on the built in model? Do those objects have bonds with
it has just every Rhino object like as is an object. So I modeled them as solid walls. I modeled them as solids. And so I'm, if you and then I also gave them layers. So it's giving it the GLZ is the name of the layer that I gave it. So those are my windows. And then these I put these on the walls. And that's just because it's from Rhino, we can't name the objects like you could do from like an animation software. And so I just put them on layers so that I know what to select.
See all the things, checking.
I'm checking the ones that I want. No, I just want the walls. And I'm going to do that for everything that I want to source in separately. So I'll do it. I'll make another split. And here I'm going to do my source object. And if I preview this, now I'll see that. And then I'm going to make a null for my source. And then I'm going to do another one. And I'm going to select, I didn't name it. It's just on the default layer. But this one is my air. So I'm going to call this. And I actually don't need the glazing because I'm not going to use it. But I'm going to call this air. The source is my heat source. I could call that something else. I could call it heat source. Call it heat source 1. And we'll call this air. The air, the reason I need a volume for my whole wherever I want to pump in arrows or pump in smoke or pump in anything, I need something to fill up with points or something that I can track. And so I need the negative volume of my space, basically. And I'm gonna fill that with little points and fill it with smoke so that I can see the air moving. And if I want a heat source, I need a volume. If I want a collision, I need a volume. And so air is I didn't name it. It's just on the default layer. In the Rhino model, it's just the negative of I made a volume that's the negative of the whole building negatively. So you could do multiple spaces if you wanted separately. But you typically wouldn't need this like for what most people would use this piece of software for. But for us, we want to simulate the way the air is moving across the whole volume. So we don't usually, like if you watch like Houdini tutorials online, there'll be like a puff of smoke. But like that's not what we're interested in. So we need actually like the whole volume of the air. Um, so yeah.
Another version of tab to access.
Oh, I don't know. I've always you can right click. You can right click. Yeah. Um and then what I'm gonna do actually is I'll just put the flag on the walls for now so that the walls are the one actually instead of doing that, okay, I'm gonna make a merge. So in Houdini, this merge thing it's very useful. You merge like you can merge almost anything, and this is just going to be. I'm going to make another null. I'm going to call this output, and this is just so that if I wanted to output different things, I could just easily plug them into here, and I'll set my flag on that. And then yes. Yeah, you can. So if you hold shift, you can move everything that's above it. And you can also just go to this layout tab and say layout selected, and it'll like do it for you. But I typically don't like the way it does it, so I don't know. I just do my own way. If you hold shift, it'll let you move everything above that node. You can select all of them. And if you hold Y, you can cut a wire. You can also align, like you can go like align nodes vertically, align nodes horizontally. Okay. And then I'm going to do one other thing here, which is I'm going to go to this material palette up here. And I'm just going to drag like one of the default materials, like a clay. I'll double click on this. Actually, I think I need to bring back my parameters tab here. And then I can just give it a color. Yes. Okay. So there's this little thing up here that says material palette, and you can just pick one and drag it over. And then if you click on it, if you have your parameters window open, it'll open the parameters window. And so if you don't have it open, you can click on this plus up here and go to the parameters and get it like that. And then this is very much like any you know, it's the same as any software. You can give it transparency. Yes. Yes.
I just have at default object line, default object.
Let me look at it.
Just read.
Oh, that's a different model.
Wait,
That's
what?
the old model. So that model
great.
just has less objects in it.
Great.
You're fine.
Okay.
You can do it on that if you want. It's the FBX2. I just called it test model 2. Yeah, so that is like I closed the parameter window that's usually here. And so you need it. So if you click on this little plus, it lets you make a tab, and there's all these defaults. And the one that you're looking for is this parameters one, which is this, all the normal parameters that are typically there. Let me see. Yeah, you just drag it into the.
And then you.
Yeah, there they
and
are.
then there the thank you.
I don't even have.
Yeah.
Get back.
And then you're.
Get back to the normal stuff. You can just like, yeah. Then you can just hit back. You can just hit this back arrow a bunch of times. Yeah. There you are. Yeah, like I have to say, when I'm in something, I have very little idea personally how to get back. I always get confused, but like if you go to this like this tab over here, and then you just hit this back button a bunch of times, it'll like eventually get you back out of everything. And that's because this is like it's just all of the Houdini has like a bunch of context, and so like we're in the we're in like a separate kind of place when we're doing materials, so you kind of just have to exit out of it. I don't know if that makes any sense. And then you can do a material node, and you can go up here and you can select the material that you created, and it will apply it to the thing. Okay, so I'm just going to pause, and if anyone has questions, I can come around for a second. Okay. It's another node called material. You click on it, and there's this material option, and you click on the little. Let me look. Yeah, it's that. Yeah, that. Yeah, click on it. And then under the materials, if you click on the plus next to the material and extend it, yeah. Uh-huh. And then you gotta move it into the chain. You can just, by the way, like you can also just like move it in there and it'll like, yeah. And then you gotta turn on the preview flag of the last thing. Yeah. 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 So like you just gotta make a material node. Yep. And insert it in here in between there. Yep. And then you can click on the flag. Yep. And you can plus the little plus and click on it. And then if you turn on the output flag, there it is. And if you want to change the properties of that, you've got to go back to the material editor, click on this and change the things. And if you go into specular and scroll down, there's a transparency and you can drag that up. It's like under the it's in the material tab again. You got to go back to your material palette.
But it's in specular transparency.
There's a material palette right there. Yeah, and then you click on that, and then there's a transparency. Yeah. And you can just drag it up. You can drag up the trend. Yeah.
Oh, gotcha.
Wait, it doesn't show up. It doesn't update the model.
It depends if you have the let's make sure, go to the okay, and then go back to the other thing. Let me see the models. And go to the oh, you don't have the render, you're not in render.
Oh.
Go to smooth shaded or something. Or,
Oh, I see. And then render it. If you add, we don't have a render.
you're right.
Yeah.
Where does mine work?
Okay, then your favorite area.
Right. Why does this appear?
Yeah.
Yeah, mine is very good.
How did you do? I think you're the place I too much.
Yours doesn't show any transparency either. It's just
Your
like,
transparency isn't working.
Yeah, mine is really good.
Only my transparency is working.
what happened to the render? There used to be like a render of like a GPU.
Oh yeah, once I increase transparency, it just vanished.
Right? Yeah.
Yeah, we're in the same boat.
Are you guys?
Shaded.
Oh, oh, wait, what?
You didn't have it on.
Oh,
Go to the back to the map then. And hit back. You go to this thing. Oh, you do have it on. So go to the material file. You click on the flag and drag up the thing. Yours vanished completely. That's exactly
why does mine work?
Yeah,
Yours
how's yours
works.
working
I
again?
don't know. Car did some.
Let me see if I can fix it. Yeah.
This is your material.
And then I don't know.
No, this is material clay. Go back into material. Clay. Oh, clay what? It's normal clay.
Yeah, I've allowed one.
Oh, it's too
Like, you know what to do.
How do you create a new material with copy paste and changes?
I just started from here.
From here to here?
Yeah.
Okay.
Ryan, is it working for you?
What's your display settings? Is it you already changed it?
It just runs.
Oh.
I don't know why that's not working. We'll solve it, but I don't know, is yours working or not? Let's see if you can add transparency. If you need it,
You put a wall.
Yeah.
Yours all, everyone's just.
Where have you find the clay?
Natural.
Scroll down. It says
That's fine. Oh, even weird colors. Wait for me. What if you change the color? Does it change it to like pink or something?
Okay, so here.
Yeah, see if that affects it.
No, leave it there, go back to your map, hang there, go back.
The pink work.
Okay.
It's pink.
This one?
No, just
Oh, yeah.
Up here now. Go to material. I don't know why that's happening. And I will, and it's in the problem.
Because you, is it because
But for now, it's really actually like not the most crucial thing. We can do everything else without actually needing to show this transparently. So, I would like, if possible, to just have you show it solid for now, and let me see if I can figure out with you why that's happening. Okay. Oh, I remember. It's this. This button. Display materials on objects.
Yeah, but that's already.
You already had that clicked. It's just
Without it, you get the whole thing.
If I change the material to just the default. Oh, no, that's doesn't.
it works for you. Okay. All right. Okay. Okay.
Yeah, I turned off.
you said that again, yeah, what do you do?
Oh, I just changed to lighter black.
Oh, well, I just turned this off and then I turned it
So clay
on.
is just-
Oh, and I changed.
Let's try different material.
I turned off a little bit.
Wait, just like glass.
You got to click on this little button if you don't have it selected to display the materials.
I think like this.
Oh.
Yeah. And then you have to have it on smooth shaded with this on. if that doesn't work for you, try changing the material. And if that doesn't work for you, we need to meet after class. Okay.
Yeah. Okay. Well, okay, I also adjusted it. I also changed the translation. I want to make sure that.
It doesn't matter. Okay. Is everyone okay? Can I go on a little bit? Okay. I am going to oh, you have to do one other thing, okay, which is you have to add before the output a transform node so that you can move this up and down or around if you want to. And I'm going to move it down a little bit. You should never move anything like in the original object. You should always move it with a transform node. Okay.
You turn the gumball again for transform.
Enter. You just hit enter in the viewport. Yeah, I just wanted to move it down because I mean we don't have to actually. We cannot move it down. I just did it to align with what I did before, but we don't have to do that. Okay, and then you need to make a separate object, and that separate object needs to be the place where the airflow is. So here you go geometry again, and you can call this, you know, simulation or something. And then inside of that, you need to drop a pyro simulator, a pyro solver. And now we need to bring in all of our sources, okay? And when I set up the pyro solver, I want us to change it to this dense. Almost every solver, almost every tutorial you see is going to use the sparse solver, but that's only going to solve for where there is smoke. And we need to use instead the dense solver. So it solves for everything, the whole entire space. And then we need to also go to this boundary tab and we need to enter a maximum size. Because that is going to be the size of if you otherwise it'll just expand infinitely in space and crash our computers. And so this size this is where you set the size and this is where you set the center of the thing. In order to visualize that, I always create something. I'm going to make a box. And I'm going to set that to the size that I'm imagining right now. I'm just going to do 10, 10, 10. And put the template flag on so I can visualize what it is. Does that make sense? So now there's an issue with Houdini, which is that even if we're using the dense solver, like it'll still only solve for the advection. That's the word in the advection of the velocities where there is smoke. So like if I have smoke down here and I have a heat source up here, it won't solve for it unless we create like something hidden in the background that tricks it into thinking that there's stuff everywhere. Okay, so what we need to do is create like just a very very low dense fog everywhere. And so what I'm going to do is I'm going to do a VDB from Polygon Dump that in there. And then that'll turn this into a distance VDB. We need to change that into a fogged VDB. It's 10 by 10 by 10, but I'm going to scale it later on based on the size of the imported geometry. So right now, before I'm going to also create something here. I'm also going to create a null and call this bounding box. And then I'm going to make another null here, and I'm going to call this background fog. And I will source that into the Pyro node. And then in the Pyro node, I'm going to go to my sourcing tab. And these are all the sources. So essentially, what happens is I have a source volume and a target field. A source volume and a target field. And I only really am going to care about I'm not going to care about this flame. And this one is for sourcing in velocity, like if you want to source in wind. So I'm going to delete this flame tab here. And you can make many of these. Okay, so you can click this little plus, and I can have like 18 sources for density. So I don't need to, and I can have different ways of sourcing them in. So that's what we're going to do. We're going to have a background density, and then we will source in like our active density if we want to actually see fog or not. So I'm just going to call this, I'm going to make this background density. It's just right now, this is, if you look here in this VDB, it's set to default. The name is by default density. And then that in here is the source volume density, and it's going into the target field density. So Houdini you could change all these things, but the names are very standardized. So it by default creates what you want. So I have it sourcing into the density, and then if I activate this Pyro solver, and if I were to play this, it's just going to just keep filling it with density forever and ever and ever and ever and ever. If you look at this, there's an operation here, and these are the ways in which it sources. So copy is just going to set it exactly equal to whatever the source is. Add is going to keep pumping it in forever and ever and ever. Pull and blend are going to be trying to return it to the value of the source slowly. And maximum or minimum is going to take whatever's the maximum of the existing values. So if this is higher, it will be this, and if it's lower than whatever's already there, it will just be ignored. So since this is a background fog, it's not supposed to affect anything, I'm going to make it have a very low value, which I haven't done yet. I'm just going to set it to maximum, meaning that if there is no fog there, it will make it that. And if there is fog there, it's going to ignore it. So basically now it's always making sure that everywhere throughout this volume, there's some fog always there. And what that's going to do is it will activate the simulation all for the entirety of space. And then in order to make sure that is a very low value, okay, I need to do something else. And this is the sort of confusing part of Houdini. But you need to do a volume VOP. And you need to insert a volume VOP here. And then if I go inside the volume VOP, this is what lets me edit the properties, set up a sort of a little bit of code to edit the properties of this thing. So I've already devised all of the things that we're going to use. I made things that I think I've tried to figure out what I think is necessary for us to get these things to work the way we want to. So I don't think you have to master this, but I think there are other ways to do this. Okay, like I could have gone into my Pyro solver and I could have set the source scale to something very low, but that's more confusing. I want absolute control over this, and so what I'm going to do is I'm just going to this, okay, I find confusing because it brings in just a lot of parameters by default. And the more kind of global way is to do a bind. And then if you click on the bind, you can give the name of the parameter that you want to bring in. It's called an attribute, okay? And it's confusing to know what attributes exist. Like you just kind of have to know, by the way. But you can also look at the geometry spreadsheet, although I have to say for volumes, it's not going to work. So like if I click on this thing and I mouse over it, if I go to this info, you can see the fields there, density exists. So like the way these chains work, okay, is that unlike Grasshopper, where every chain is an operation that does something with inputs and outputs, doesn't work like that. It's its own thing. Basically, like there's just some attributes, and every one of these that are stored in here, and here they were created, called density, and then all these things are just modifying the previously existing attribute that is stored in there. So there's like all of these things are containers for like a set of attributes. And so right now we have only one attribute, and you can find out what that attribute is if you go over the thing and you go to info. You can see all this information, which is all very confusing. But down here in the volumes, you can see there's one volume, which is, this big. It's got a million voxels, and it is called density. So then if you go into the VDB, you can change this name to density, and that will give you access to the density field. And you won't be able to see any of the values. There are a million values. So all we have is the access to the field name, and then if we do an operation, it will do that operation to all million values in the field. And so if I type multiply, I'm going to put a multiply in here, and then I'm going to do another bind. Okay, it's called bind export, and I will also call this one density. So this is the same process for every single time you do this. You choose a field, bind it, do some operations, and export it to the same exact field that you imported. You cannot create new fields. You have to do that in some other way. You can't give it a different name. All you can do is overwrite the values that were previously there. Okay, this is not creating a new parameter. It's not creating an export parameter. It's not importing anything. All it's doing is giving you access to previously existing values, changing them, and overriding the values that were there before. This is a bind export, and this is a bind. And they're really the same node. It's just this, whether this button is checked. It's just a preset that there's two of them. And so then if I go here and I go middle mouse button over this and I go promote parameter, it gives me this little flag. I can click on this flag. I can call this multiplier. I can go, and then that little thing is now something I can change globally here. I can change this multiplier to something extremely low, like 0.001. Yeah. So in the volume VOP, I did a bind. I change the name of the bind to density. And then I did a multiply and then a bind export. In the bind export, I also name it the same thing that I named it before. If I were to call this something weird, I'll show you what happens. I'll call it Batman, okay? And then if I go out, you know, it's just going to be the same density that it was before. Like it just will do nothing. It won't create like a Batman parameter or anything. It just will do absolutely nothing. Like this has to be it has to be named the name of the thing that I already have. And that thing is always going to be density or temperature. It's just like always going to be that. Yeah, so then you right click on this and you go promote parameter. And over the input, and that gives you this little extra flag. And then you click on that and you can change this label here, whatever you want to call it. It's now you're naming a control basically. And then if you go back out and you click on this VOP, I'm going to change the name of this VOP to multiply density. If I click on this VOP, I can change this multiplier now, and it's changing the thing inside. So I can essentially now, if you look at this, there's nothing is appearing because I have such an incredibly low amount of stuff. And if I were to play this simulation, let me make it something sort of in between. Let me make it like 0.1. You'll see it slowly sort of fill up. By the way, the other thing I wanted to say is like this is going to be the same every time. So all you have to do is like you could open up the one I created and like replace the parts of it. You could save this thing again and replace the parts of it. Just replace the geometry and change the size of the bounding box, as long as you understand like what the parts are. So you're not going to be like recreating that every time. We're just going to use it again and again and again and again and again. So this is just a way to make a background fog. Oh, you mean in here? In the multiplier, there should be like a constant. If you do it correctly, there should be a thing here called that is based on whatever you called it in here. If you go promote parameter, and then you click on this, you should be able to. Can I help anybody? Yeah.
So just
This is if you click on the BBB, whatever flag, if you click on the blue flag, yeah. You got to change to. Then middle mouse click on this one and go promote roles. And then click on the little flag. Those are the things that will let you. Just this page. You don't want to. So click on the little green thing. And change it from input number 2 to multiply. Yeah, the label. is the thing that's
It's not such a, it's like, it's a straight forward.
Yeah.
yeah. And then if you go out of this thing here,
It's the form
and
increase
you work on this, there's the multiplier. So right now it's 0. So if you turn on the flag of this, you got to get this thumb down. Yeah, exactly. So that's just multiplying originally the density is just automatically 1 everywhere. So we're just setting it to some multiplier of 1.
Like how one.
Oh, you need to do a bind, click on this. And say
Usually I can't
export
tell it's
on
increasing. That's
like
you're increasing that's minus
do a bind
I can't tell.
type tab, do a bind, and then you can pump into the input and you can change what again. Yeah.
This is set to max with that one.
No, but
It
this,
like fixes it. What do we just do add?
you gotta change that to
Then it's
density.
gonna work. It's also great.
Yeah. So then basically like the bind gives you access, I don't know why it's called bind. It gives you access to the existing density values that are already there. Then you do some things to it, and then you overwrite the density values with the new density. So you have to,
You already did add.
It's up to maximum.
Yeah,
yeah, well, it recognizes the, go out of here.
is it increasing?
It recognizes, click on this. It recognizes the name of the field that you gave it there.
Oh,
So when you created the VDB, you gave it the name. And then you, yeah, that's right.
how do you set the maximum?
That's right. Anybody else? Yes.
Question, Carl.
Mhm.
Like, when I click, like, I can't tell if the fog is increasing in density.
I can't tell it either. Let's go in here. And like, yeah, if it's set up correctly, it is.
Okay.
And if it's not working, we'll know later.
How do you control the maximum? Even like, how do you cap? Like, how do you set the cap limit of the maximum? Is it just 1?
Well, it by default it puts 1 at every single value.
Okay.
So then you're multiplying it by 1. You're multiplying 1 by whatever multiplier
Okay,
is in here.
so pretty much this
That's the value.
Is the maximum.
That's just the value.
Okay.
Right now it's everywhere.
That value.
It's the minimum because
It starts at a minimum.
like if you go to the Pyro solver, this maximum is means it will take the maximum value. So it means that this value that you're pumping in, since it's so low, will be the minimum density everywhere.
But can you like increase the maximum?
Well, right now this is all constant. So there's a million values that are all 0.1.
Oh, okay.
So like it's not changing.
I don't know.
Well, okay, I have to like a little history here, okay? This idea is very confusing. It just so happens that fluid simulators were originally created about moving smoke. So they're all built around these ideas. So there's always when you do that VDB activate, basically it takes a cube that used to be a polygon and divides it into a million values. It's not quite a million because it's also fuzzy. So there's a million points, and then between all the points, it's blended. So it's an incredibly rich data type, but it automatically sets them all to 1, unless you do something else funny to create them in different values, which we will do, but we're not doing it yet. It's just all 1, and then we're just lowering the values because we want to be able to visualize some smoke. We don't want to see this. We want it to be super low. So we're just making it super duper duper low. And then this is doing nothing for us other than activating the simulation everywhere by having some data in the background that it's aware of. So and then I think you guys keep asking me how do you this is the maximum. I think that has to do with the fact that this is not actually the value in the simulation. This is the value in the source. So in the simulation, there will be all sorts of different values everywhere. But this is the source value, and the source value of this particular source is always going to be constant. And then it's a question of how you add the source to the simulation. So like we have, what we're going to do is we're going to have a background density source. We're going to have an actual density. We're going to have a temperature, background temperature. We're going to have a source temperature, and we're going to have a velocity source. And we're going to pump all of those in to the simulation. The simulation is going to run, and these will get added on every frame in different ways. So the background density will always make sure that it's there. The source density will instead do something different. It'll either add itself successively each frame, or it'll do like a pull where it's trying to return to that. Like if I wanted to like put myself as like a heat source, my body doesn't change temperature. So like I would use a pull for the air around me is always kind of like slowly returning to the temperature of my body. If I were going to put like a fire, like I would maybe pump in like heat every frame. Or if I were going to like, no, that doesn't work. Fire is also constant. If I were going to do wind, right? Like I would pump in the wind every frame, adding to it maybe. I don't know. I think the add isn't really very physically accurate. Like if you think about it, nothing adds forever. So we're typically going to use pull or maximum. Maximum is to set a baseline condition, and then it's confusing, right? Because it is the minimum, but it's a comparison. So if you have a simulation where there's like 50 values, it's going to look at all those values and it's going to compare the value here, which might be like 10, to the background value, which is 0.1. And if it's the background value, if this value is 0, it'll make it 0.1. If this value is 10, it'll make it 10. So it just makes sure that it's always there. Yeah. Did you have a question?
So when you say pull and the maximum, you're referring to the operation parameter in a pyro solver.
I'm referring to the in the pyro solver, the sourcing tab. Like it has a source, a target, and an operation. So there's pull, maximum, add. Yeah. So you can source in temperature, density, and velocity in different ways. I deleted the flame because we're not going to set anything on fire. If you I'm going to add another one, by the way, and it'll do nothing. I'm just going to make one. And down here, I'll call this density 2. Density 1, I'm going to call it. And that field is going to also be density. There is no density 1, so this is going to do nothing, but I'm going to put this pull. So what I'm going to do is like I can just keep adding other things, other VDBs with different names, and sourcing them all into the density field in different ways. So like I'm going to add a temperature, I'm going to add a velocity, I'm going to add a smoke source, I'm going to add a background temperature, and I'm just going to all bring them in here. And I'm going to basically, the internal field, okay, is you can see it. It's very confusing the way this is just a big menu here, okay? But like actually, if you go to the fields tab, you can see the fields. Here they are: flame, temperature, density, speed. I mean, actually, it's annoying because Houdini doesn't actually expose all of the fields. Like there's many. There's density, there's temperature, there's pressure, divergence. There's all the types of fields that you need to calculate fluid flow. and they have names, and those names are set by convention. So like if you go to the output here, you can see like here it's outputting density, temperature, flame, velocity, and CD. I don't know what the CD field is, so I always get rid of this, get rid of the flame, and then you can see we have now the same fields everywhere. We have in the fields tab, density, temperature, and velocity isn't exposed, okay, here. I don't know why. But in the output, we have. So what I said basically what happens in these things is you have all these sourcing fields, then the simulator runs a bunch of times. The simulator has internal fields where it's storing the data, and then you choose which ones of those you want to see. And those are the output fields. So like there's basically like an object in memory that's all these fields, and the simulator is doing action on them every single second of every single millisecond. Does that make sense? Is anyone lost? If you are, it would make total sense to me. Please speak up. Yes. Yeah.
Like all the operations happen inside the module. Like you can't multiply it on this level, like outside of
That's right. Houdini is context dependent. So like right now I'm in what's called the SOP context. I'm in the geometry context. So I can only do geometry types of things. And if I was in here, I can do operation type of thing. And then this is confusing because this is dynamic solver. I shouldn't be able to have this. I should have to go into the dynamics context to do dynamics types of things. It's just that this has all been packaged. It's the only one like this that's been packaged into the geometry context. So like if I dive in, really what it's doing is like doing a bunch of stuff in the dynamics context and exporting it. And then the other thing that's weird is you can nest the geometry context in a dynamics context. You can just endlessly embed things inside of each other, but they give you access to like different nodes. Yes.
Can you explain the difference between source volume and target field?
Yeah, the target field is like if I were to set up an old Pyro solver, okay, like the original kind, I would have to do a .NET, and then I would go in here and I would do a Pyro solver, and I would do a volume source, and I would do a smoke object. And the smoke object would go in here and the volume source would go in there. And this is what's really happening, okay? What's really happening is that there is it would look like this. So like this is what's going on inside. There's a source, a storage area, a solver, and an output. And so like the source is just it has no real dynamic identity. It's just a way for me to add values to the universe. So like I have to have something that exists, and like in the world, the source is the fact that like wind is blowing from all the way over there. But like in a simulated environment, like I have to source in wind from something. So I need a source. And then I need somewhere to store the updated values. Like I need to store at all the million points in the simulation, I need to store every data. That's not the source, because the source is just the input. This is the stuff after the simulation has acted on it. And then the simulation runs here. So the simulation runs, overwrites the source, and then checks whether there's anything new to come in. Then it runs, overwrites the source, checks whether anything new is coming in. Runs, overwrites the source, checks whether anything new is coming in, and then the output is happening constant.
With the smoke object is source, it's not the right object.
The smoke object is the storage. This is the source. This is the solver.
But so to link that back to like source volume and target field. So source volume is the right hand volume.
This is the target field.
This is the target field. So for the names, like what?
Like if I were to go, if I click on this, okay, it's much more apparent. Like this is the old way. Like like it just has all these fields and I can name them and change them and like, like uh there they are. Velocity, density, temperature, fuel, divergence, burn,
But
pressure, rest,
Oh,
combined.
you said you have to match the like in your example earlier in like in the new pyro solver and source volume. Well, under density, for example, source volume is density, target field is also density. When you created a new density, your source volume became density one, and you said it no longer works.
Oh, it's because I don't have a density. Like I'm sorry, that's
The
confusing.
target field is still density. So
Like basically what I'm gonna do is like I'm gonna have density. I'm gonna have background density. I'm gonna have like smoke emitter 1, smoke emitter 2, and all of those things are going to get sourced into the density field. Now the names are confusing because the density field is internally already defined. So like it's a little confusing. I don't know how to say this. Like I have to have something that I'm calling density because otherwise um uh um
density already exists. It's built into the pyro solver. So like you just then when you change the name to density, that field doesn't exist. So
I could name these things anything that I want. They don't have to be called density. Like I could name this, like if I go here, let's not call it density. If I go here, I could change this to, I'm going to change this to background fog. And then when I go into the pyro solver, I'm going to go to the sourcing tab and I'm going to change this from the background fog. The target field has to be density because that's internal to the pyro solver. But the source can be anything.
So the two densities were previously referring to different densities.
Different thing. One was referring to the source and the other was referring to the
It
target.
just happens so that you named it density above.
I named it the same thing because everyone always does it that way by convention, but it's let's not do it that way because it's super confusing.
Is it like concept in computer science where like two functions have like the same name, but you're
like if you look at it's a little clearer like in my code, which there's so much I want to do with you guys. It's like a little overwhelming. I will like in my code, okay, like there's this is the field. It's like a bunch of numbers. This is the source. And then that is like going in, and then inside there's like separate storage. Here's the temperature field in here. There's the temperature field. So like there's a source that's you set before the simulation, and then there's a field that the simulation sets for you. And that is like, so I can call this anything. Like I shouldn't have, let's call these other things. Let's call them like, like background, let's call this background temp into temperature. Let's call this, let's call this like wind 1 into velocity. And then I'll call this smoke source, smoke source, smoke emitter. Let me call it smoke emitter into density also. So this is like these are the internal storage, and these are the names of my sources. None of these are active yet. Like actually, like we don't have any of these. Like so, the only one we have is this. All we've done so far is source density from this background fog that we created into the density field. Does that make sense?
Yeah.
Okay. Because it's name. Yeah. And that is like called density because somebody has already set it up that way, and we are using previously existing work.
The target, so the most important thing is that target field matches whatever is already defined, but source volume has to, the name of the source volume has to match the VDB from Polygon.
It has to match the name when you create the VDB. So you create the VDB, you name it whatever you want, and then this is not changing. By the way, this is now broken because I have to go in here and I have to change the bind to background fog, and I have to change the bind output also to background fog. So that is honestly the only reason I wanted to do this with you guys, because you won't be able to use my code, my names, if you're adding other sources. You will have to open the VOP and change the names. And that's because now I no longer have a density field. All I have is a background fog field. And then I can create, now this is operating on the background fog field, and now it's coming into the background fog. Does that make sense? Okay. Let's add another source. This one's going to be like an emitter, okay, so that we can actually see something. So in order to do this, I am going to I'm just going to make a sphere, okay? I'm going to make a sphere, and I'm going to like keep the flag on this on, but preview this. And I'll probably make a transform node. And I'm going to bring this down, -4. And here I'm going to do a VDB from polygons again. And I'm going to copy this multiply density here. And now I'll multiply this to like 0.5 or something. Then I'll make another null. Call this fog emitter. Yeah, there's a polygon. You can change the kind, do the polygon. And then now the one thing I have to do, remember, is that this field is going to be called, this has to be changed to a fog VDB. And now I got to give this a name. I'm going to call it, what did I call it? I forgot. No, that was the other one. This is the source. This is what I'm going to call fog emitter, okay? I'm going to call it smoke. I think I called it smoke emitter. And now I have to go in here to the VOP, and I have to change this also to say smoke emitter. And I have to go here and change this also to say smoke emitter. And yeah. And then I have to, and then I'm going to call this, let's call this smoke emitter. And then I can, what I need to do now is I need to have a merge node. And this merge node is just going to have all the volumes coming into it. And if you look on this, if you look at the info here, if you look at the info here, you can see there are now two fields. There's a density and a smoke emitter. Basically, I'm combining volumes into a single overlapping collection of volumes that are then being brought into the thing. Very confusing. It's not like any software we're typically used to using, where we're making all these volumes and we're combining them into a single object. And they're not really um this they if you look at this, this one only has 465 voxels, this one has 1,000,000 voxels. And if I preview that, I copied it over and then I went into it and changed the names.
The smoke emitter, what's the temperature due?
The smoke emitter is what I'm honestly like, the smoke is not really necessary. It's just a display thing. Just what I'm going to do is I'm going to add a temperature source in here and it'll pull the smoke. So like, that would be the next step. And then you don't have to display the smoke. You could display the arrows or you can, who knows? I'm just doing it this way for now. Can I help anybody? Yeah, you need to go into the Pyro solver and you need to make sure the other density is on and that it says smoke emitter and that the target field is also density. And this one's going to be pull rather than maximum.
On card, add another source in another source volume.
This is not a particularly interesting source, but like, you know, we can add we'll get into that later, I guess. Like, or like I have I don't really want to get into the dynamics of making the source sort of interesting yet. I want to just like show you how to activate the temperature.
Don't see my little ghost sphere.
It might be because the name is not correct. Like
You should down inside volume you should change it
And go to meeting.
I didn't choose the.
You have,
you've got a field called density.
Oh, I didn't do that.
So
I didn't.
if you go up here,
Yeah.
click on
If
your
I change the name here though,
it's still called density there.
second one.
So it's kind of simpler if you just give it a test.
Yes.
There, you find it works.
That's right. Although like we would have to change one of these because like it would be confused if we had two density sources. You have to change one of them, or you could combine them earlier in some way. Like there are other ways of combining them, like, but I just think this is the easiest way. There couldn't be duplicate density sources that would get confused. You could have made them. You can do something called like a VDB combine. VDB combine, and we could have combined them earlier, but it's very confusing. It's much easier to do it this way. And now I'm literally going to do the same exact thing again with a temperature volume. Okay. So like now I'm just gonna make another box over here. I'm gonna make a transform. I'm gonna move this down, make it a little bigger. Actually, let's make the box bigger. Let's make it like 3 by 3 by 3. And let's move it down. And then I'm going to do another VDB from Polygon. And I'm going to call this temperature source. Let's call it heat source 1. Heat source 1. And then for now, okay, let's just make a null and call this temperature. Let's call it heat source 1. And let's also bring that into the merge. Now, you notice I didn't scale the temperature, and that's because it's a little more confusing, okay? And I think for now, let's just leave it at that. And we'll deal with setting the temperature later on in a second after we activate things. So if you go back to the Pyro solver and we go to the temperature, we can turn this on and we can call this heat source 1. Make sure I named it correctly. Heat source 1, sourcing into the temperature. And you can see when you do a pull, it also gives you the option to do an acceleration and deceleration strength. So that's how quickly it's sort of returning to the existing temperature. So I play with these a lot in terms of trying to get the simulation to look correct. If I'm bringing in heat, like that's an important parameter to be adjusting. And now I'm going to go to my shape tab. And you can see buoyancy is on. So I'm going to open up buoyancy. And you can see 3 settings. And there's the buoyancy scale, the ambient temperature, and the reference temperature. So this is in Kelvin. So it's 0 is 207, 0 Celsius is 273. And the ambient temperature is what I referred to previously, is the 0 temperature that is the reference temperature that the Boussique approximation is referring to. And the reference temperature is something else that is a scaling factor. So basically, between 0 and 1, 0 is 300 degrees Kelvin, and 1 is going to be 3,000 degrees Kelvin, which is really not very useful, given that we're not trying to make a nuclear bomb simulation. Okay, so we're going to change those numbers to something a little more physically plausible. So like I think like I always get confused, but like what's like 10 degrees Kelvin? Like 280. So let's just set it to 273, okay? No, that's 0. That's too cold. Let's do like 10. So I can set this to be the ambient temperature be 280, and the reference temperature would be like 322 or something. And that means that like anything colder than 10 degrees is going to sink. And anything hotter is going to rise. And the value of 1 refers to the is 322 degrees Celsius. Kelvin. Okay. And then I created a thing, and if you open my file, you probably are not in it right now. So, um, uh, we need to, but over here, I created a thing, which like this. Okay, I don't really wish I wish we didn't have to recreate it, but like it's what it's doing is it's scaling things like the same way. So it has a high reference, a low reference, and a value. And so like I think this is the easiest way to scale temperature. You have to remember that it's in Kelvin. So we have to always like uh subtract to Kelvin, but like let me see if I can package this somehow. I've never done that before. Save uh should have figured this out before. That's a good idea. Let's take a quick break and I'll try to figure out how to save my node. It's a great idea. Okay, take a quick break. Before we take a quick break, I gotta say one thing, okay, which is like we gotta get going on the wind tunnel. Okay, because and I swear to God, I know it's annoying in a way, but I promise you, like it is simply not okay to always be in the digital environment. Like the thing that I found out for myself when I graduated is that the longer I always would have a tendency to slide back into sort of comfort zone of always working digitally. And you must force yourself to get your hands dirty constantly, or you start to lose touch with whatever it is that you're actually working with. So I think we can have tons of fun simulating things in the computer, but if we don't actually blow some air, like it's not actually very meaningful, even if the other thing ends up being a mess. So everyone needs to set up a meeting with me like right away over the next week. And Elliot is going to make a schedule for making things. And I promise it's not going to be all that difficult. I've ordered all the materials, by the way. I've ordered the fan, I've ordered all the steel, I've ordered everything. It will all be here tomorrow. So like it's very exciting. I bought a fan, by the way, and it was not good, so I'm gonna return it. And like we're gonna go with the Miles idea. We're gonna go with yes, we're gonna go with the variable current operator. And the reason for that is I realized that all the cheap fans have the control on the side that has to face into the wind tunnel. So we need an external controller, regardless. So that will be here tomorrow. The aluminum is arriving at the GSD tomorrow. They're very angry at me, and by the way, it's going to be a little annoying because thanks to Trump, there's a back order on all metal, and so we're going to have to use slightly smaller sheets than I anticipated. So we're going to waste some aluminum. It wasn't getting here for like another month, so I ordered slightly smaller sheets. So we're only going to have 48 by 48 sheets, so there'll be some wastage, which is unfortunate for the larger pieces, but maybe it'll be easier to work with. You won't have to store a big sheet at your desk. So all of that, and also very cool. I wanted to show you how well this works. This is the blackout car stuff. It makes a perfect seal because it's for cars. So like I ordered just a 40, the whole test section is 48 by 48 by 48 basically on roll. And I ordered a 48 by 48 by 48 sheet of this. So we'll just smooth it on top. So everyone needs to schedule something with me. And Elliot has so kindly agreed to help us figure out a schedule for look at your deliverable schedules for your other courses and try to help us plan a little bit when we're going to finish things. I have to say, if it doesn't happen on the day I scheduled it, we may push it back. But we need to do it before the rush of no Zund cutting at the end of the semester. So that's the plan. Okay, take a break and I'll figure out how to export this. Okay. Oh, and I ordered little bolts like this. So you guys, this is like not this, but it'll be made like. The bolts will be like that. Our little bolts for the metal will be a little longer than that, and the wood bolts will be big. Yes, I saw that. Yeah. Yeah. That's perfect. That's you, I think, that cut that.
Very familiar with me. Everything makes sense now.
It's all connected.
Yeah. So I worked 12 to 4 on Saturday.
Yeah,
That's when we can.
See this?
Oh,
This is the seal.
I might.
That's aluminum with the car shit.
That's okay. I'm
It's
trying
like
to get
airtight.
covered.
Yeah.
Whoa.
It's made to like an iPhone cover. It's supposed to like smooth out as you push on it.
Whoa.
That would be screw.
How do you cut
Would
the
that fit in the
aluminum? Like the
We'll cut it on the Zun. The Zun can cut aluminum with the router.
Oh, it made these holes. That's nice.
Yeah, I
Oh,
mean,
so
we
it's
won't
gonna
do
clamp.
something that fine. This is
Okay.
just a different kind of a model.
I think the test is gonna take like 5 minutes to route, so we can just do it on Saturday.
Okay, well then I can keep on making these.
Yeah, tiny little bolts. How are you guys, by the way? You guys are all my students. I feel like I'm so rude. I like pretend like I haven't had you before, but I don't know how to do it. Like I'm very awkward personally. Like I don't want it to be like, like I just assume we all know that it's exciting and fun that we're all doing things again.
Yeah.
We all wanted Carl Biz season 2.
Exactly.
Carl, do you have like a layout or like a zone file by chance that
I don't
reference?
have like this is why it's important to meet with me to talk about it. Like I made this thing in here and there are like this is the wind tunnel. So like there are like ideas that I have about how one should convert this into a file.
Like, because I think Iggy, me, and George are doing like, yeah.
This is very complex. Yeah. It's not like it's not a cone. No.
But is it developable?
It is
Kinda.
it is doubly curved. But it's very easy to make, but I need to show you how to do it.
Oh, okay.
It's not like instantly apparent.
Is it you approximated the doubly curved surface into a single curved surface? Is that what you did?
Since the time that I had you guys, I discovered since the time that I had you all, I discovered something very amazing.
Quad panelization.